Okay, welcome back. This is part 2. In this video, we're going to assume that we have a linked list already, and we're going to look at a fundamental process of walking through our list. Couple reminders. If I make this declaration here, what happens? I set this to null, and that means what? It means there are no nodes to point to. Furthermore, because I set it to null, I can check to see if head is equal to null or if head is not equal to null. Now let's suppose we have a list. How many nodes are in the list? 4. Okay. Now, how do we get to the nodes? How do we get to this node here? I want you to imagine, if this was an array and not a linked list, I can go directly to any of these. We call this random access. I can say a sub 3 and that gives me the 7. I can say a sub 0 and it gives me the 4. But a linked list is what's called a sequential data structure. The only way I can get to this one is I must get to this one first. That is, I must visit the data in sequence, starting where? At the head. Now, we're going to illustrate what happens, and imagine that as we go through the list, we need a finger to work with. So this pointer P is just going to be a finger. As we see it, it moves. It starts at the first node, it moves to the second node, third node, fourth node, and finally, our finger says, oops, there's nothing to point to. All right? And when there's nothing to point to, we declare ourselves finished. So let's see what is required to make this happen. All right? So when I first get started, I set P to head, and that makes head and P both point to the same node. A reminder, this node that contains 4 in this link, I can say that this is node P. Why? Because P points to it. I can also say it's node head because head points to it. So the first node that we visit is node P. Now, suppose what I want to do is just to see what's in this node. Well, you would say, once I'm at node P, just output the value that's stored there. And we know what to do. We just say cout. If that's what we want to do, we say cout. We have access to the node through P. Whoops, we're going to say P point. And we want the value. Ooh, I got my operators missing, don't I? Okay. Less. Okay? So that I can display the first value. Now here's the question. How do I get from this node to that node? Well, the picture says I can get from this node to the next one by following this link. What does that mean? That means I want to change the value of P so that P doesn't point here but P points there. So how do I do that? How do I do that? Well, I got to reassign P. I got to say P is not P anymore, but I want P to point to whatever node that comes next. What node is that? P point next. So basically, this statement is the means by which I move from one node to the next node. What's the assignment? P is assigned the pointer, P point next. And this will keep going. Okay, is that pretty clear? What do we have to do here? Once we're done here, how do we output this? Go just same thing as you had up there. How are we going to move from here to here? Same way as that. Is that clear? So let's just label these things. Let's call this A. Try to circle it. Let's call this B. And circle it. So how do I process this node? I do A. Whatever A is, that's what I do. How do I move to the next node? How do I move to the next node? I do B, right? And when I'm down here, how do I do this? I do A to display. I do B to move on. Do you see a pattern here? Yeah, we're kind of repeating the same step over and over. It's A, B, A, B, A, B, A, B, A, B. All right, so how do we go from here to here? We're here now. So what do? We say A. How many nodes are there? 4. So how many A's should we have? 1, 2, 3, 4. What's the last thing we have to say? Well, whenever we have an A, we need, where am I? Yeah. When we have an A, we need a B. So what's B going to say? B is going to say, watch this, we got to be this. We're going to say P is equal to P point next. Right. But what's P point next? Isn't this it? This is another word for what? No. So at this point, P becomes no. All right? That's why we draw it this way. P really isn't pointing to anything. In chapter 17 of the textbook, they do linked lists, and they don't draw it this way. Don't like that because P really isn't pointing to anything. It's a value no. So when do we stop this whole process? P is supposed to point to a node that has a value, but once P becomes no, it is not pointing to a node that has a value, which sounds like we really should stop now. Y'all catch that? So we need to stop. So it looks like we have a loop going here, does it? Does it? Yeah, what kind of loop? It starts off with this. We're going to call this, can't use A anymore, we're going to call this Z. Got my alphabet backwards. First step is Z. Next step is I've got to do some things. I've got to do some stuff. Looks like I need a loop that has A in it, followed by B. Sorry for this. My drawing is not good, y'all. I'm making a mess. This is a block. Okay, is that clear? This is a block. These are the two things that get repeated. How many times do they get repeated? Well, we don't know. We don't know how long the list is, so we cannot use a for loop. What's our only other choice? It's a while loop. While what? While there are nodes to point to. When are there nodes to point to? When P is not equal to no. Yeah. Okay. All right. So this basically is the pattern for walking through any list. This is the pattern. Now here's the question. Is the pattern difficult? Heck no. How many steps are there? One step, 2 step, open a block. You always have to do B because B does what? Moves to the next node. What about A? A is going to vary depending upon what you are trying to do. So the only thing that's going to vary about this pattern, well, this pattern consists of this, B, and that. A depends upon the job you're trying to do. All right? So let's just pull the code up and show you what it looks like. I need a finger, which I call P. I started off with the first node, and as long as I am pointing to something, I do whatever I want to with the content of node P, then I move to the next node, and I keep this up. And that's the pattern. Notice that if we have been using an array, the pattern is different because with an array you know how many elements, so you can use a for loop. but it's the same process. This is the one fundamental thing that you really must memorize, what this pattern is. And then you must say, for every circumstance, do I need the pattern? When do you need the pattern? When it is necessary to visit every element in the list. With that, we will close.